Hello, everybody. That's me. So what I'm going to talk about is how to make a game in Three.js. So first, I want to thank David to invite me when I talk about Three.js, a Babylon guy. Respect. Serious. OK, so let's try to have fun in the process of writing these Three.js games. So what we are going to talk about is creating the first pass will be create a basic object in 3D with Three.js, then to build a map with the various extension we're going to have, to add some sound, because sound is often misinterpreted in game, let's say underestimated. We want to have more sounds, and how to link as well, how to link your usual web content with WebGL. Something like, suppose you want to link whatever content you got on the web inside your WebGL. We're going to present how to incorporate all that. After that, we're going to digress a bit and show some tricks you can find on some of the minigame I made and what could be done in the future. I have some crazy ideas, so like 2 days ago, and I'm going to present that to you. And after that, how to run on mobile, on hopefully how to do cloud gaming, just toying cloud gaming, let's say. So first, the introduction of what is Three.js games. So what is Three.js? This is to display 3D graphics in your web browser. Not that displays 3D graphics, that's not specific to WebGL. That's an effort led by Mr. Doob. That's a very cool guy, Spanish guy, you can quite well known. There is quite a large community around it. Three.js in itself is 100K after gzip. And the web page is there. On internet is working, excellent. So you got various demo all around. You got huge amount of example, maybe 200 example. You got the list here. I won't show every one of them, right? So this is Three.js. This is general presentation. This is only focusing on 3D display. You got a scene graph, if you know what it is, I hope. You can import assets, various models that you can have from various modeler. There is like from importer, you can import from 12 formats from memory. You can do processing. There is many kind of renderer. There is so many things, I can't list them all, and this is not the purpose of this talk, so I'm going to stop there. So this is first the collection of renderer. This one is the usual WebGL renderer, so you render a bunch of sphere, not too hard. This one is a lot more technical. This is called deferred rendering. Just like that, at 60 FPS, you got 50 lights. This is quite a bit. You cannot do that with direct rendering without trouble. So you can do that with deferred rendering. Deferred rendering is supported by Three.js. Another renderer which we use quite often is called the CSS3 renderer. CSS3 is able to do CSS 3D transformation. That means that you can move objects, DOM elements from your page. You can move them as if they were in a 3D space. This is quite cool. We're going to show a very important usage of it. And what you see here, there is absolutely no WebGL. This is normal web page. On each of these small square is usual div or an image like an image tag, nothing to do with Canva or WebGL. So this is the basic renderer. There is a Canva renderer, which renders a 3D inside a Canva 2D. So that's pretty cool, but that you can see this is slow, very slow. But we do funky stuff like reflection or stuff like that. There is a software renderer. So this one is, you can see to which point Mr. Doob is a geek. Software rendering is you render everything in JavaScript as if you were in a very old computer like in the 80s with no GPU at all, and you trace every pixel by hand in JavaScript. And there is an actual Z buffer for people who can notice. This is super geeky, absolutely useless in real life, but I guess you found that fun. About useless things, an ASCII renderer, so you can render usual scene in ASCII. Yeah, you can upload. It's not me, but you can upload, that's cool. And very recently, like last week, we even have a ray tracer. So ray tracer, that means that you build your scene in Three.js, and after that, you're rendering with ray tracing. So as somebody said, well, I believe ray tracing was hard. And Mr. Doob answered quite nicely. Ray tracing is super simple. Fast ray tracing is trouble. Because as you can see, it doesn't render that fast. Each and every pixel is computed with 3G, with a JavaScript in ray tracing, so that's really, really, really slow. But that's fun that you can do it. I mean, that AlterQ who did that like 2 weeks ago. Okay, so this was the ray tracing. So Three.js is only display, but a game, you can read. But a game is a lot more than just displaying things on the screen, right? So to do all the rest, we have something called 3x extensions. In those 3x extensions, we package various usual things that you do during a game. For example, we package physics, collision, sounds. So physics is like, I don't know, you have a ball, you drop the ball, or it's bouncing on the floor with some various collision. Sound, well, sound is Web Audio API. I'm going to speak more about this API later. Very nice API if you are doing game, by the way. Input, input is whatever you want. Keyboard, lip motion, Kinect, I don't know, usual gamepad that you have on your Xbox. I don't know, inputs. Or even device orientation when you move your Mac if you want. Let's not do that now. On various effects. All that is packaged as 3x extensions. So what is 3x? That's a very light extension system for Three.js. By very light, I mean like vanilla.js. I don't know if you remember, but 3 years ago in NGF2014, we talked about this concept. It is basically, you have no dependency at all. This is just a bunch of conventions that everybody agrees follow, so nobody step on each other's foot. Maybe I did some grammar error here. So currently, 3x extensions are the following: is internet is nice with me? Be nice. If internet is not nice with me, we're going to have trouble. Come on. It's working. Excellent. So, so you can see various things. You got terrain, you got day-night cycle, you got realistic physics here, for example, this one here. So you got this demo. Here you got like 500 balls falling on pyramid without breaking a sweat. As you can see, that's 60 FPS. Each of those little earths got, I don't remember how many faces. You got bump map. There is even a normal map, I believe, or a bump map, I don't remember. And all that 60 FPS. So a lot of extension here. We're going to see some of them. Oh, Nyan Cat. Everybody wants to see Nyan Cat, guys. It's always a sound that's supposed to go out. Okay, this was not my demo. In fact, the Nyan Cat is a whole WebGL demo which existed in the past. And the guy who did this demo was maybe too ashamed of it or something. He released it anonymously. So nobody knows for real who is doing this demo. But for sure, the guy knows the code of Three.js. Thanks. Because everybody looked at the code in order to find out. OK, so this was 3x. How to make a game with Three.js? Because all that seems OK, but we need a lot more detail, right? So first, to make a game, you need a hero. You need a hero because in every game, you need a hero. A persona to embody you, something like somebody you're going to live through. A virtual self for the player to interact with. So let's just do that. let's create a hero. A hero is born. Or how to build simple 3D objects. I prefer a hero is born, it's a lot more heroic. So to mold our hero, what we're gonna do? We're gonna go for something simple because we have little times, and something very blocky, very Lego-like. We're gonna go for Minecraft characters. Minecraft characters are very easy to do in my case, and it's very important because I don't know how to use a modeler. And Minecraft characters, you don't need that. You know very well JavaScript, that's good enough. So first, let's start with a cube. This is a cube. Nothing too impressive, right? So this one is the part of, let me see if I can even increase the size of the font. This is creating a cube in Three.js. So the first part is you create the geometry of the cube, then the material. I'm gonna explain the code just after that. You unify the material and the geometry together to create what we call a mesh. Mesh, that's a fancy name to say an object in 3D. And after that, you add that to your world, which is called a scene. We have a lot of funky vocabulary. Don't be too afraid with it. That's really just funky vocabulary. So, first, the geometry. The geometry is the shape of the object. This is a very important part. This is, I don't know, a cylinder, that's the shape of the object. In our case, we are creating a cube of the dimension 1, 1, 1. That means we have a width of 1, a height of 1, and a depth of 1. So we create this. Not too hard. There is other predefined geometry like that. Let me show you. So this is a cube. Here you got the source for the cube. You got a torus, still the source here. Torus knot. Just a bunch of examples. A circle, a sphere, a plane, and a cylinder. Obviously, that's quite limitative, right? So you can import models that you make inside your best browser, your best modeler that you prefer, something like Maya, I don't know, Blender, whichever modeler you like. After that, you need the material. The material, there is first the geometry, which is the shape of the object. The material is how the object gonna reflect the light. That means, for example, if you have something in metal, it doesn't shine the same way that something in, I don't know, rock, something like that. A rock doesn't shine the same way as an object, or plastic, or water. All that doesn't react the same way to the light. So currently, the materials supported are the basic material, which is very basic. Basically, it doesn't react to the light. It just outputs what we call the diffuse color. Lambert, which is one way to make it shine, Fong, another one. Or if you want to play funky, your own stuff, you can put your own custom shader. But it requires quite a bit of knowledge already. So all that is quite nice, but that's just a cube. We need a hero. So let's duplicate this principle and have cube for everything. Another demo. Oops. This is the cube that we did. Is it hot or not? Oh, I claim it not. You remember hot or not, Facebook? Okay, this one was not hot. We had a head to think, not that hot anyway. You have let's add some arm. This is pretty cool, but not easy to work. So we had some legs. This is what looks like when you have a Lambert in white. That's not too cool. We need to add textures. And suddenly, when we add textures, it looks like something, right? So this is the usual look of Minecraft characters. Not hot enough. We want Mario skin. Because, oh yeah, all this is compatible with all the usual Minecraft skins, so I can take whatever skin I want. This is why I got so much. So, Superman, oh yeah, I like the hair, very sexy. John Smith, this guy, very mysterious guy. The joke comes just later. So, for this guy, I would like to give a disclaimer. All persons are fictitious. All characters appearing in this work are fictitious or resemblance to real person, living or dead, is purely coincidental. Almost. So, basically, it's me. That's me. Okay, so I love recursive joke because me presenting a conference about game with me on the screen, in a game, building a game, a lot of recursive stuff. So I found it fun. So we got a player now. He need more life. He need to move. So we need to see how to animate this guy. We go here, so he's walking. He say yes at the same time. Let's say he's completely still. Suddenly you ask a question, he's very agreeable, so he say yes. Then he say no. Suddenly he's very, very hungry, so he pick punch. Or he say hi from high, or he can run, or many stuff like that. Or strafing, which is pretty weird. But try to do strafing with this kind of personage, man. This kind of character, my bad. So now he's alive. It's quite interesting. We have created this personage, this character, my bad. We have created this character, and he's alive, he's moving, and he's look rather nice. So he's a golem. This is my Frankenstein. What I have done. Oh, damn, Turing was right. Turing is a joke on artificial intelligence. So now he's aware, as Turing was saying. Let's name this guy Mike. This guy is a hero of a game. So he needs a purpose, he needs a goal, he needs a quest, a motivation to earn the game. He's gonna look for love, fame, and justice. That's usual goals. We like it this way. Why? Because this is what every video game hero is doing, right? So we got our player, he's moving, he got a goal, that's pretty nice. We need a map to move it. Why do we need a map? We need a map, this way we have a world in which we can evolve. A world where Mike can become a man, a new man, a better man. So now he needs a world. Or the subtitle, which is how to use 3x game extension. Because behind the storytelling, I got some data to convey as well. So let's look at the world we have for this little guy, for Mike. So we have this guy, which is from behind. There is some mountain. There is a grass on the ground, as you can see, yes. And there is a day-night cycle. Let's wait a bit. Let's see if we can find the sun. So there is the stars. Yes, you can see the stars. And there is a sun somewhere. If you find it, you have to find the sun when it's rising or setting. There is a sun. Let's not look too far. So for that, we need, let me keep it around. For that, we need 3 extensions only. 3x grass ground for the ground, 3x mountain arena for the mountain, and 3x day-night for the day-night cycle. To show the sky, to show that the sky is moving. It's always interesting when you are playing to show the environment is moving around you. This is about gameplay, but that's something else. So what is 3x? That's a Lax extension a la Vanilla.js. Most 3x extension got a single dependency, which is Three.js. Obviously, you depend on Three.js, in my case at least. So as little as dependency as possible, not really a framework, more a bunch of conventions that we use. It's all documented. If you go to this page, you go how to write 3x model, how to do the update, how to handle the physics, the folder hierarchy, blah, blah, blah. That's rather boring, but if you write your own, you may be interested by this page. Okay, so this is our wonderful stuff. For the workflow, we have 3x, and 3x supports the modern web workflow. What does this mean, modern web workflow? It's basically you can install with Bower if you want. You can include with Require.js if you want, and we even support Yeoman for boilerplate. What is really, really, really important is all that is supported, so you can use them and have the speed advantage of when you develop. You will develop faster if you use them. But this is not required. If you don't want to use these tools like Bower, Require.js, or Yeoman, just don't. Do that with your own stuff. That's completely OK. It's all supported. So the trick is do not require it, but support it. So after that, we can do package with manual install. We can do that with Bower. So Bower, it's, do I need to define Bower? Well, I guess so. Bower is a tool from Twitter in order to include package that you can find for web browser. Package here, think about like NPM, but for web browser. That's not NPM. You got NPM for Node, Bower, that's the same thing, but for web browser. That's an effort led by Twitter. So in our case, if you want to include all the planets I got an extension where you got all the planets of the solar system. To install it, you just type this command, Bower install 3x planet, and suddenly it appears on your hard drive. You can search all the 3x extension I have written by this command. This is all very simple. If you want to include the package, you can do that with script, usual stuff. Or you can use require.js. Require.js got various advantages, like mainly the fact that it handles the minification for you. But all that is more convenience. If you don't want to use it, just don't. Now we got the principles. Let's see some extensions. So as we have said, the 3x grass ground. You got the 3x grass ground. If you want to use it, you go on the repo. You got the repo here, blah, blah, blah. You got explications, the demo, how to install it, how to use it. So each of these extensions are fully documented. You can use it. It's tested, everything. And when you got a demo loading the texture. I try to praise the god of internet, maybe. Okay, well, okay. So you got the grass. Nothing so impressive, but this way you already have the grass. You don't need to find the grass, especially when you are a beginner. You start with Three.js or with whatever library. You don't know where to find a texture of grass. You don't need to find this stuff. It is already packaged for you. It's very easy to do a mini game like that. At the end, I'm going to show various mini games that I made with that. So this was a grass ground. So to install the grass ground, super simple. Bower install 3x grass ground. Or you include it with that. And after that, in your JavaScript, you just do that. New 3x grass ground mesh, and you add that to the C. That's simple. You can put terrain like that. I'm seeing that the time is lacking, so believe me, you can put terrain. I will just show the demo. This is Perlin terrain, so every time you will launch, and this guy is working on the mountain. So that's another possibility. The blue here is supposed to be water. Babylon.js do better water, by the way. Okay, so mountain arena, so same thing. You got a mountain arena. It's very interesting to surround you. So these little things here is exactly what you get in my little demos that I skipped. In this little demo here, you see those mountains are exactly the same as those one, except that you are inside everything. So this was a mountain arena, and blah, 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 blah. Donc, as usual, very simple to include. You include the script, and after that, you do 3x. You add that to your scene, and you got 3x mountain arena. You got deny cycle. Deny cycle is funny. I took that. Oh, many of those extensions are just repackaged by me. Not all, but let's say 40% of it are just repackaged by me. This is stuff that I know which are in various demo of it, and I take it and repackage it in order to make it reusable by non-expert, let's say. So here you got, oh, see, the sun is here. So you got the sky, everything. It's nice to simulate day and night. This was the day and night. We included, for physics. Physics on Three.js. Physics is not in Three.js itself. Why? Because real-time 3D physics is hard. I mean, like, super hard. So it's a project in itself, and we don't try to do it. So we kept them separate, but interact well with them. Let me show you various demonstrations. This is a new war. I'm scared every time I launch something on the internet now. Okay, so let's load other pages. Okay, so this is physics, realistic physics, so that is computed in real time according to usual law of physics, right? Here you got some dice falling. As you can see, you have quite a lot of dice, and performance are not suffering. So it's pretty cool. Various pool ball, this weird worm, something like, no idea where this guy was doing here. And here you got a little car. Let me find the control. Yes. So you got a little car, or maybe some Greek stuff. Or you can destroy the Greek stuff. It was there for 2,000 years, but now it's dead. Okay, something like that. Okay, so Canon.js is another one made by Steep. And let me show you the demo. Click to play. So this is first person. I can shoot. If I shoot on this stuff, you can see it's moving. I can jump, hit it. I can push here. I can jump on the various square. All that is realistic physics. That's pretty cool. Amo.js. This one is cool. It's really nice. Amo.js is the history of Amo.js, or maybe during the loading of it. Amo.js is a C++ library, believe it or not, which is called Bullet, which has been converted to JavaScript with a compiler called OM-Scriptum. You probably heard of it this morning. So this very big C++ has been converted to JavaScript, and now this is a JavaScript physics library. And this is a demonstration. He's loading some cars, trying to load the cars today, I guess. Let's wait a bit until he waits the car. So all the Canon.js on Amo.js, on the Yomo.js, not quite easy to pronounce, are very easy to interface with Three.js. I made some 3x extension to make it. This way you can do it without much trouble. Okay, so we got the car. So you can see my little car. You can do the shadow casting. I go here. I got collision here. You got various cars. That's top-notch when you come to physics demonstration, because the car is very hard to do. And if you push this guy fast enough, yeah, okay, we got some collision. This demonstration is a lot simpler. This is domino. This shows correctness, at least. That means that the domino are acting as they are supposed to be. This one is funnier, at least better than the demo. This is slow-mo. So I wanted to untitle this, especially because we are in France, and on va leur mettre la pâtée comme en 98. Sorry, I don't know how to translate. We're gonna crush them like in 98. Maybe that's right. So that's slow-mo, and the slow-mo of it is make it look cool. Okay, so this was Yomo. After that, Mike, he got a world, he knows how to move, that's pretty nice. Now he's gonna go party. Because he's supposed to be a teenager, no, right? So, I'm supposed to have some sound, I'm sorry. Can you add the sound?
Jeff, est-ce que tu entends le son?
So I'm Mike. I'm in Batman in my wonderful disconnect. Hello, my name is Batman. Our face. Go look for love. So I lost Robin. Have you seen women around? No. Batman doesn't seem interested. I keep looking for Robin.
Wait.
You missed something. I'll tell you. Maybe have you noticed that you missed something? The camera. He missed something. Unfortunately for it, so for women that's gonna be hard. So it's quite embarrassing. So the guy gonna play video game, right? Is that what we all do? Okay. Go back. So that's over. He leaves the party now. So what was interesting is you like it a lot, right? Okay, cool. So to do that, we use Web Audio API. So Web Audio API is a new API, which is for sound, and it's aimed for games. That means it has been designed for the games, not just to do some basic sound effects in your web page. So it's based on OpenRL for people who know that. So it's rather complex. It's like WebGL. WebGL, if you try to write it raw, no way you will do that. I mean, that's so complex, you won't do it. Well, OpenRL is a lot simpler. But Web Audio API provides various things which are very interesting for us, game developers. Sound localization. So what is sound localization? Is I am in the 3D space, I got something on my left, I hear it on, I believe that's my right. Okay, so on my right, so I hear it on the right, on the left, behind, above, everything. We got Dopplers. So Doppler, what is Doppler? Is you are close to a road, you got a car passing by, you entend meow, and meow. The deformation, this deformation of the sound is what we call Doppler in scientific part. Convolvers, many, many things. Basically, all what you want for sound, you can get it in this API. This is really interesting for us because it got very great accuracy, no latency. Nothing in the worst in a video game is when you shoot, so you press the trigger, the bullet is going away, I guess. You hear bang, like 1 second after. Pick, bang, doesn't match. It happens still today with the audio tag. If you want to do that with the audio tag on Linux, that's not a good idea. One other very interesting part of the Web Audio API, it uses very little CPU consumption, even if you got very complex sounds. So for that, I have written a little helper that I started to publish some blog posts about it. These little helpers are made to make the Web Audio API very easy to use for game dev. I'm a professional game developer. I'm CTO of a company called Bellula, doing Three.js games. And I took all the usual typical case that you hit for sounds, okay, and I put that in little helpers. You can find that on GitHub, and you can install it easily by Bower install WebAudioX, as usual. So to use it, very simple. First, you initialize it. Then you create a sound. You create a sound, unload it, and after that, you play it. Not that hard, right? For localization, you will thank me if you try to do it yourself, is if you do game sound for a listener, follow object 3D, the listener of the sound gonna follow this object 3D. So that means that I spare you all the mathematics on matrix conversion. It has been quite hard to do. It has not been done by me. It has been done by Ilmari, sorry, I don't know the guy, the last name of him. It's on HTML5 rocks if you want. So this is a listener. So this is what's gonna listen. That means this is the source, not the source, but where you are supposed to listen. Where if the sound is on the left, it's gonna be on the left of this listener. After that, you play the sound, and the sound can follow as well other 3D objects. For example, with my wonderful explanation of a car passing by on you listening, the character is the listener, and the game sound will play inside the car. So the car, the game sound will follow the car itself and will produce this wonderful Doppler effect. Yeah, I like to say that. Okay, so after all this sound, all this painful realization, let's say, you go home and play video games. Why do we do that? We do that because we want to explain how to link your WebGL with the usual web content. Demonstration. Demonstration. Okay, loading almost. Not that bad. So this is a game console. Doesn't look like much, but there is quite a bit in it. So first there is a text here. Where is my mouse? Yeah, okay, there is a text. As you can see, this is interactive. Every time I pass the mouse on it, it looks like a link that I can link on it. This part as well is interactive. It looks like a web page, right? In fact, that's the interesting part. This is an actual web page, guys. You see, I scroll like a web page. I got over. I don't know if you see my little mouse, but I got over. I got everything like that. This is an actual web page. Why? Because this is an iframe. Inside my WebGL, I got an iframe. This is quite nice. Let me show you what you can do with it. I go on the blog in order to get here. This is my blog. This is a demo I did a while back. And what you can see is, you see this little guy is going through the screen. So for people doing actual WebGL, that means I got a Z buffer, an actual Z buffer here. And this in front is not at all something like I simulate to be a YouTube player. This is an actual Flash YouTube player. If you press here.
Hello, everybody.
Okay.
So this is a new stream.
Okay. One of me is already enough. And, but you got actual Z buffer. It's very important because suppose you got all your web content that you want to have, you can present that easily inside your WebGL scene. This is very important because the web is very interesting because you can link all the content together. This is basically in the name. The HTML is hash is for hypertext. Hypertext in English, I guess. So we need to be able to link everything together. So we come back here. And you can actually play video games. This is the interesting part. Suppose I go here, I click MMO 3D. It's loading. Doesn't seem like loading. So MMO 3D is a very interesting part. That's a multiplayer game that I have written, which work even on your mobile, by the way. Okay. So it's really loading. I will be short on time. Am I allowed to sleep? Not that much. Okay, so here you got this guy. As you can see this guy on the other screen. And you can even here change. I can interact with the page which is behind. I can even change my name. I can say next game frontier, and that will be my new name. I can interact with my web page inside my WebGL. This was the goal of this demonstration. Okay. So you can play the game inside the game. This is pretty nice. I'm not sure that's that useful, but that's nice. You got a menu for all the games. If you get close to the TV, let me show you again. If you get close to the TV, you are in full screen, which is quite interesting. Suddenly you can play a lot better, right? Suppose you go on this game. No? So you got this one. You can move the camera and notice the granular sound. Point. Well, oh, no. Okay. All right. Come on. Not all the sound are good, right? Okay, so you can play. Still, the actual game is going around us. Ah, yeah. This is the important part. If I go here, well, you don't see because of the resolution, but you are still inside the WebGL. So you're there. So there is a denied cycle. All that was the demo time. So as I just shown, the TV set is done. I will spare you the boring detail because I have quite a lot of slides still. Okay, so you can interact with the mouse, as I have just seen. You go here. The API for that is very nice. It is basically jQuery. I copied jQuery on that. So you take your 3D object, you do on-click, and it's going to react every time you click on the object. This is done at the pixel level. That means that either you touch the object or not. This is very precise and, unfortunately, very slow. So you can write some text in the 3D, not hard. You create a mesh like that. This is like that I created those two texts. You can choose the font. There is like 20 fonts. I don't remember. There is this guy to show the demonstration. And after that, I'm going to go directly to Wendy because I want to talk to you about Wendy. I think you're going to like Wendy as well. 10 minutes left. OK, so DOM event is super great. HTML mixer, I did a super blog post about it. So HTML mini game, so I did a Pong as well. This guy is cool as well. Stellar set, I will just give you Stellar set just for the fun of it. Stellar set are just a game that I did in 2 weeks, thanks to all the extension I got. Can I have more because it doesn't load fast enough? No kidding. So you get the sound here. Yeah, let me put the sound. That's the same sound you can play. And what is funny is when you touch the guy at this, you like to hear that. I will do that every 2 seconds if you sleep. OK. So this was something called bad TV effect. OK, so that was Stellar set, as I have been reminded. So that's all the extensions I have used for this game. After playing the video game, he got tired and started to daydream. What would be the best video game for me? I'm young, I'm full of energy, I like games and I like girls. So I want to create a girl for myself. So for himself, sorry. Almost. A game where people could find their match partner. This is what is in my head. He thinks about Diana. That's Diana. I'm sure you're going to love her. Diana appeared recently on the web. And this is the top notch when it comes to avatar in Three.js. If it loads, it has to load. Be nice. Easy loading, excellent. See, interesting. The head gonna come, guys. OK, so the head is there. So first things, Diana, look at my mouse. That's pretty natural. You see that there is a button to remove the clothes. Let me warn you already. So this character can talk. Hello, you.
Hello, you. Hello, you.
He's moving as you can see, look at the skin of it. Pretty nice, right? I love it. OK, so let's stop this girl. OK. She's still looking at my mouse. Look at the eyes, guys. That's very precise eyes. Excellent eyes. Just the eyes. Let me show you the eyes, only the eyes. Just for the eyes. When you are a geek, you don't care about the girl, you look at the eyes, right? That's what they say. This is real time. This is real time. This is shaders. This is excellent. You can circus, so you can change some stuff. You can put the eyes property, so you have to be an absolute expert to tune all that. you can make it like a cat. A lot like that. Those eyes are exactly the eyes of Diana. And if you are doing a game or you are willing to make it realistic, there is a saying which is, the eyes are the window of the souls. So it's very important to have the eyes to be actually, to show the feeling of it. So because I'm a nice guy, I'm going to remove the clothes, but only from far. Believe me, the guy who modeled this girl was not thinking about his grandmother. That's really sure. I do that from far, but you can go close at home if you want. Not that I don't do that, obviously. Okay, so you do that. You can say, oh, wow, that's pretty good already. But, oh, I'm just in time. Okay, I got up to 29 or 39. J'ai combien de temps encore? 4, okay. So if you do that, you got very realistic eyes. Suppose now that you are mixing this wonderful avatar with Oculus Drift. Oculus Drift is something funny where you put those very discrete glass and you see this. That means each of your eyes see a different image. So you actually see in 3D. It is very nice because when you move the head like that, you move the camera as well. So it's very instinctive. Just imagine you mix Diana with that. That's one thing. After that, I don't know if you know lip motion. That's like a very small Kinect that you pose close to your computer. Because of that, I don't have to touch the computer. The lip device gonna detect the movement of my hand. My both hands gonna be there. I'm gonna have this very discrete glass, and I can interact with Diana. All that for very little money. All those devices are off the shelf. This is very important. So nobody has done that already. But I bet that less than a year, I mean, let's admit it, right? The Minitel has been paid by the given industry, starting by X. There is an X in the middle, an X at the end. So basically, porn has paid for the Minitel. I'm pretty sure this will happen in the porn industry very soon. So on top of that now, you got multiplayer that you can make on WebRTC, which is audio-video conference, which is open standard, by the way, and it is peer-to-peer, so very cheap to run. All of that means that I give a very strong, let's say, future for WebGL game. And after that, I can explain cloud gaming, but I'm not sure. You have time for questions? One or two questions. Anybody got questions? Or I show Diana again? No?
So if you've got a question, yeah. This guy is completely crazy. I love him.
I wonder about the including an iframe into a WebGL
yep.
renderer. Have you tried to include the same renderer of the first WebGL scene into an iframe, into one, and do some kind of crazy recursive thing, or it will break at some time, maybe?
You can do it, but very fast. In fact, the power of the computer are going to crash. And you're going to have some wonderful Mac error, virtual Chrome stuff, or something like that. I'm very sad.
Okay.
No, I tried.
What about performance? How many Diana could you render at the same time, for instance?
Well, it all depends on your test, I guess. But I haven't tried, honestly, and I haven't tried. But something like that, 50 without any trouble. On my computer, at least. A computer which is a MacBook Pro, nothing special, of 2 years. It's quite efficient. The eyes are harder, but it's quite efficient. You could easily display 20 like that without trouble. Any other questions?
More question on his girlfriend? No?
I can give you her address.
Okay,
No?
so, well, thank you very much, Jerome.
Thanks to you.